This unit is going to be 1.6 and 1.7. I can use scientific notation to write large and small numbers. Okay, so first we're going to write out a formula for what scientific notation is, and then we'll talk about how to use it. So I'm going to put scientific notation. Has to be in the form a times 10 to the nth power, where a has to be between 1 and 10, and n is an integer. So n can be positive, n can be negative, but it can't be a fraction. It has to be a whole number. So here's an example at the beginning. An example would be to write 326 million using scientific notation. So we're going to move the decimal point so that a is a number between 1 and 10. So I have to put the decimal point after the 3 and before the 2. If I put the decimal here, it'd be too small. 0.326 is less than 1. If I put the decimal here, it'd be too big. 32.6 is greater than 10. Here would be too big. 326 is greater than 10. Then I say times 10 to some power. And I figure out what power by counting the number of times I had to move the decimal point. So the decimal point, we moved it to here, so we moved it 1, 2, 3, 4, 5, 6, 7, 8 times. So times 10 to the 8th power. So this is standard form. Then we wrote the same number using scientific notation right here. And there's another part of the rule. If n, so the exponent up here, is positive, you're going to move the decimal to the right. If n is negative, you're going to move the decimal to the left. That means we're talking about a really small number if the exponent's negative. So it doesn't mean your number is negative, it means the number is less than 1. It's going to be a decimal smaller than 1. So you'll have problems that will say to rewrite numbers that are in scientific notation in standard form. So we're going to say write in standard form. And standard form is how you're used to seeing numbers. So for our first example, we'll do 2.48 times 10 to the negative third. So remember, we said if n is negative, we're going to move our decimal point to the left. And I'm going to move it to the left 3 times. So I'm going to take it was here, I'm going to move it 1, 2, 3 times. So now it's 0.00248. The decimal was here, and I moved it 3 times to the left. Example 2, let's do 4.816 times 10 to the 6th power. My exponent is positive, so I'm going to be moving it to the right. So it was here, I'm going to go 1, 2, 3, 4, 5, 6 places to the right. So it's going to be 4.816. We're moving it 1, 2, 3, 4, 5, 6 places to the right. And again, my exponent is positive, so I move to the right. It's a number much bigger than 1. And for our last one, let's do 3.2 times 10 to the negative 4th. My exponent's negative, so I'm moving it to the left 4 times. 1, 2, 3, 4. So it's going to be 0.00032. We moved it to the left 1, 2, 3, 4 times. We're also going to do ones where we go backwards. So the directions will say write in scientific notation. So it's going to give you a number in standard form, and we're going to write it in scientific notation. So for the first one, let's do 369 million. So we're going to move the decimal or we have to put the decimal point between the 3 and the 6. If we put the decimal in front, it'd be too small, it'd be less than 1. If we put it anywhere else, it's going to be greater than 1, or greater than 10, sorry, so it'll be too big. Remember, this number has to be between 1 and 10. And then we say times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Be times 10 to the 8th because we moved it to the right 8 times. For example 5, let's do 0.000512, so 0.000512. I have to decide where to put my decimal point so that the first number, a, is between 1 and 10, so it has to be after the 5. If I put it here, it'll be too small. If I put it anywhere else, it'll be too big. If I put it here, it would be too small. Here it would be too small as well. And then it's going to be times 10 to the negative. I know it's a negative exponent because this number is less than 1. And I had to move the decimal to the left. So it went to the left 1, 2, 3, 4 times. So 10 to the negative 4th. And then for example 6, let's do 0.0046. The decimal has to go between the 4 and the 6, so that a is between 1 and 10. And then times 10 to the 1, 2, 3, so negative third power, because I went to the left and because this number is smaller than 1. I'm going to do one more of these. Let's do 215,000. And that's going to be 2.15, so that's between 1 and 10, the 1, 2, 3, 4, 5th power. It's going to be positive 5 because I'm moving it to the right. The last thing we have to talk about is operations with scientific notation, so adding, subtracting, multiplying, and dividing. So I'm going to put adding, subtracting, multiplying, and dividing in scientific notation. And to do that, you're going to put the number in standard form first. So we're just going to do one example, and I'm going to do an example with adding. So if we have 6.32 times 10 to the 9th plus 4.67 times 10 to the 8th, I would put them in standard form first. So I'd have 632, and I have to move the decimal over 9 times, plus 467, and move the decimal over 8 times, 1, 2, 3, 4, 5, 6, 7, 8. And then I would add those two, which gives me 6,787,000,000. And if I want my answer in scientific notation, I can just put it back in scientific notation at the end. So it'd be 6.787, so that the first number is between 1 and 10, and then times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9th power, because I had to move it to the right 9 times. So I would do this for any problem where you're adding, subtracting, multiplying, or dividing with scientific notation. Put it in standard form first, and then do the operation, and then put it back.